it. We're just going to do it. And so moving on to the second phase, we have the second phase of our business, which is prospecting. So there no mining effort, no extraction effort could be complete, of course, without choosing where you want to go. Now, there are, as of this morning, there are 8,931 near-Earth asteroids that we know of. Is that right, Tom? Okay. So we have a population of almost 9,000 near-Earth asteroids, which represents, by the way, my friends, 1% of the near-Earth asteroids that are larger than 50 meters. So there are almost 500,000, there are between 500,000 and a million asteroids that we expect to find out there over time that are greater than 50 meters and that are close to us in terms of the near-Earth capability. That's an extraordinary amount. We only know 1% of them right now. And so our first phase beyond the development of our technology is to prospect. We're going to do it by launching a space telescope, a series of space telescopes, which are our Arcid 100 series, which you're going to see. And then we're eventually going to launch swarms of spacecraft using our Arcid 300 series to these targets as we characterize them, as we learn about them. And eventually, into the third phase, which is the extraction phase, we're going to decide, based upon the characteristics that we find out in the prospecting phase, exactly where we're going to go and what we're going to do. And so, and which asteroids we're going to go after in terms of extraction. And so we'll look at things like, what exactly are the materials that we find on them? Okay, where are they? Where are they located exactly? What's their state vector? What's their spin rate? Okay, what are the markets? By that time, when we're talking a few years out here, after we've had a chance to do the prospecting, where are the missions? Does NASA need gas stations on the way to Mars or on the way to the asteroids or on the way back to the moon? What are the markets we're talking about? What are the periodicity of these asteroids? Some of them are in great orbits, but they don't come around often enough, or they're in low energy difference orbits, but they don't come around often enough. So we need to study these things and really understand what are the top targets. And once we have those targets, that's when we're going to go and begin to extract. So let's talk about number 3, which is who has made this possible. So I'd love to go into much more detail with you on our plans, but suffice to say that we're at the beginning. We're already beginning to build hardware, but we're still at the very, very beginning of what we're doing here. And I would like to just take a moment to thank and talk a little bit about each one of our investors, or at least a partial list of our investors who've made this possible. So we've been very fortunate over the years to get to know some of the most incredible, passionate, visionary people who have started not only companies but industries, and who also share a passion for space. And so one, of course, we have to acknowledge first is one of my very close friends and business partners, Charles Simoni. Charles has had the pleasure and honor, and we've had the pleasure and honor at Space Adventures of launching him into space twice. I am super, super proud and super honored to have come to know Charles. And as you can see from the building in which we sit, Charles really does give back and has a dedication to the future, not only for education, but also for believing in us enough to help us try to create this new industry. And so we also have been fortunate enough to include in our company 2 of the key people at Google. So we have Larry Page from Google, who is just one of the most brilliant people and greatest entrepreneurs of our time. Eric Schmidt from Google, who is not only an advocate of space exploration, but also of the deep seas, and truly an explorer at heart. We have a number of other individuals. I'm not going to have a chance to go through all of them. One of my really close friends and somebody who's been sort of watching us from the start is Ross Perot Jr. Many of you obviously know his name and the fact that his father ran for president, but Ross was the first person to fly a helicopter around the world. He flew a helicopter around the world, and his helicopter hangs in the Air and Space Museum. He's a huge advocate of space and aviation, and very honored to have him involved with our company. In fact, I believe we're going to be able to take a call from Ross here during the Q&A session, so we'll be able to hear from him a little bit. I'd also like to acknowledge Rena Shulsky. It's not a name that you've heard. Rena is an entrepreneur. She's a developer. She lives in New York City. She was our first investor. She goes way back into the days of Space Studies Institute and following space, and she was our very first investor, and she will always have that recognition, and I'd just like to honor her today for making that first commitment to Planetary Resources. So I'm very thankful for our investors. I could tell you stories about all of them, but at the end of the day, when we sat down and talked to them, they said there's really 3 things that we're excited about. Number one, Eric, despite the fact that you and Peter are good salesmen, we know there's a lot of risk in what you're doing, okay? You can tell us how great it's going to be, but we know that there's a significant probability that we may fail, okay? Because we're trying to do something so audacious, everything could line up great, and then there could be an event where we fail. But we believe in it anyway, because we believe that attempting this and moving the needle for space is worth it. So we're into it. We believe in that. Number two, we believe in your team. The engineers that you've attracted, the people who have landed spacecraft on Mars, who have deployed tens of millions of chips out into the world coming from Intel and a real industry, these are the people who can actually make this happen. It's not going to take hundreds of people. It's going to take a few dozen people to do this. So we believe in that team. And number three, of course we're interested in making money. If it's successful, we hope to make a lot of money. But we're not interested, we understand that's not going to happen overnight. Okay, we do understand that the pot of gold at the end of this rainbow, if it is successful, will be big. And so those are kind of the 3 points that we heard from our investors, and we believe those are great points, and we're very thankful for that. And so finally, as I wrap up my comments here, and as we conclude, I'd like to just say that I think I've been blown away by the fever pitch, if you will, of the media the last few days. It's been amazing to watch the blogs, the commentary, the speculation out there in the world about what are these guys up to? Is this for real? Are you kidding me? It's been amazing, and all except for maybe 5 or 10% of the comments you see out there of the reaction that people have is super positive. People, I think, have been very excited about even the idea of a possibility of asteroid mining. And the good news is that actually what we're talking about here and the pathway we're putting forward, I think, is even better than people thought. Because if we're able to successfully deploy and mine for water, we're going to create a network of propellant depots, of gas stations that literally open up the roadways to the rest of the solar system. So it's going to drastically reduce the cost of deep space exploration. Second, if you go and study and look at the estimates of resources and elements and their peak rates and how much reserves we have as a world, you might be shocked to find out some of the very common and needed elements that are getting pretty low here over the next couple decades. And so we hope to create through these asteroids, through the development of space resources, a future where we can count on having space resources enable our abundance and our future generations of prosperity right here on Earth. You know, we see the future of Earth as a Garden of Eden, as a place where we take care of the Earth and we protect the environment and we do our heavy industries and our mining and all that sort of stuff in space. These asteroids, as Tom will tell you, have lifetimes of 30 million years. They're not out there forever. They come and go. It's a very interesting cycle, and we need to grab them, quite frankly, before they do some damage to us. And we can use those asteroids to grow our prosperity for the future. And so as I'm wrapping up here, I'm really excited for you to listen to my colleague, Chris Lewicki. Chris has been a friend for 20 years. Chris and I have known each other since the early days of space, of the Students for the Exploration and Development of Space, SEDS. And I was running the University of Virginia chapter, and Chris was the national head. And we sort of went in different directions, and Chris took the path of very quickly ascending to the very top of the robotic space exploration programs at NASA, at the Jet Propulsion Lab. And when Peter and I started this company, we sat down and we thought about, man, this is a big challenge, and it's going to be a lot of tough stuff to talk about and to do. Who do we really get to run the technical part of this? I mean, who could it possibly be? And we both looked at each other, and we said, there's one person who can do it, and it's Chris Lewicki. We had no doubt in our minds that he was the guy, and when we called him up and said, Chris, it's time, let's go do this, that's where we got to where we are today. And so I'd like to welcome you, Chris. Come up here, my friend, and share with us some of your vision for the future.
Good morning, everyone. I'm Chris Lewicki, and I'm an asteroid miner. I'm very excited to be here today to introduce our philosophy, our roadmap, and our people. And as Eric was remarking, landing things on Mars and the great things that both Eric and Peter have done We've all been involved in things that are exciting, things that create wonder. But in the last few days, I've realized that we've all been waiting for something that creates hope. So let me tell you about that today. Planetary Resources' goal is to develop the resources of space. And in order to achieve this goal, we're going to need to dramatically reduce the cost of space exploration, and specifically asteroid exploration. We're going to combine the best practices of aerospace. We're also going to take a Silicon Valley style of innovation to create robotic explorers that cost 1, maybe 2 orders of magnitude less than current systems. So what's being done today in space, we've gone to asteroids, we've visited them, but it's costed us hundreds of millions of dollars, upwards of $1 billion in some cases. And we're going to do it for tens of millions of dollars. And we're charting a path that gets us to single-digit millions per prospecting spacecraft. That's 2 orders of magnitude or a factor of 100 lower. And that is out there. That is bold, that is crazy, and that's what attracts me to this, because those are the types of advances that we need. Those are the things that are going to kind of raise the capability for everyone and give everyone better access to space. Our economy has shown that innovation in cost and innovation in market, those 2 things are every bit as important as innovation in capability. We're creating simple, elegant designs that can be executed by our small, very focused, and very expert team. And although we'll hold ourselves to the highest standards, we're going to aggressively take and accept risk where it's appropriate. Our philosophy will allow for the rapid development of commercial interplanetary space exploration. So, actually, I'm going to take a break and get some water. When Kennedy said, "Let's go to the moon," we didn't start the next day and say, "Let's design a moon lander." We knew very little about the moon. All the technologies that were going to enable that had, in many cases, yet to be invented. So how did we start? We started with robots. We started with a series of spacecraft, names like Ranger, Lunar Orbiter, Surveyor. We had 9 Rangers and 5 Lunar Orbiters and 7 Surveyors, and many of them failed. And if at first you don't succeed, try again. But we had a campaign of learning about the moon, and we launched one after the next, and each of them advised us how to make the next one better. And from that experience, we learned about the moon, and we learned about how to explore the moon, and that enabled the Mercury program, the Gemini program, and ultimately the great and tremendously inspirational success that was the Apollo program. So through that, we as a nation proved our technologies. We tried out different strategies, and we also tested our team. So Planetary Resources will do the same thing to develop our technologies to access the resources of space. So our first series of prospecting spacecraft is the Arcid series. And the Arcid series is what does the prospecting. We've been working on the Arcid 101, and the 101 operates in low Earth orbit as a commercial space telescope. And we've actually got the 102 on the stage next to me here today. Rapid cycles, responding to different addresses, different needs, and creating a capability that is able to learn from the previous generations. And the great thing about our 100 series is that the derivative uses that our customers are going to find for it. We, Planetary Resources, will use this capability to look out to the asteroids, find our targets, characterize them, learn more about them. But it'll also be used to look back to ourselves here on Earth. And it's got a whole bunch of interesting features, arcsecond resolution.